Okay guys, this is Ms. O'Neill with the very last video lesson. We are dealing with 7.4 Graphing Logarithmic Functions Part 2. I will have a worksheet for you guys as your very last assignment during this continuous learning time. Thank you for hanging in there and getting all that homework done during this time, guys. I think you will really benefit from that next year. So I hope you guys are looking forward to summer break, even though it's probably not going to feel a whole lot different than what we are doing right now. But I will not be at school when we get back in the fall. So, yeah, this is my last Algebra 2 lesson, possibly ever. Okay, so our essential question is, how do I transform the graph of a logarithmic function? And so remember, we've done transformations all throughout this year with all different graphs. So if our parent function is the function f of x equals log base b of x, then to make a vertical reflection, we would just put a negative in front of the log base b of x. That makes it flip upside down, right? To do a vertical stretch, actually, let me write this here. A vertical stretch or shrink is going to be if we put an a in front of our log, and it would be a stretch when a is greater than 1, and it would be a shrink when a is between, oops, didn't write when a is between 0 and 1, a fraction smaller than 1 would make it a vertical shrink. To do a vertical translation, remember, we would put a k value outside of our logarithm. And so if k is greater than 0, then your graph goes up. And when k is less than 0, our graph moves down. And a horizontal translation then would happen when we have a value inside with our x. Sorry, my handwriting today is terrible. If we put in our function x minus h, then that would be a horizontal translation, and when h is greater than 0, then our graph would move right, and when h is less than 0, our graph moves to the left. Okay, so same as it has been all year. So let's see if we look at a couple equations, if we can figure out what the transformations are. So for number 1, it says describe the transformation of f of x represented by g of x. So what if we take the basic parent function, f of x equals log base 2 of x, and g of x then becomes negative 3 log base 2 of x. So there are actually two things going on here. The first is we have this negative sign out in front, which if you look back at our notes from just a second ago, that would be a vertical reflection. And then we also have the 3 to deal with. So our 3, because it's in the A spot and it's bigger than 1, that would be a vertical stretch by a factor of 3. And so for number 2, I've got this 1/2, oops, in front of my logarithm. That's again in the A spot, but it is a number between 0 and 1, which means this is going to be a vertical shrink by a factor of 1/2. And then finally for number 3, we've got this +2 inside. We've also got this -3 outside. That +2 on the inside is in the H spot, and remember it should be a minus sign, so this is actually minus a -2. That's what made it a positive. So because that value of H, -2, is less than 0, this is actually moving left. Or if you guys remember my inside-outside rules, whenever it's inside, it does the opposite of what it looks like. Or I think Mr. Baker said the stuff inside is big fat liars, and so it's lying to you. It looks like it's going right too because it's positive, but it actually goes left too. So this is a horizontal shift or translation left 2. You could just say moves left 2, that's fine. And then that outside number 3 is going to move my graph down 3 because it's in the K spot, it's less than 0. It does what it looks like it's going to do when it's on the outside. So it moves the graph down 3, like it looks like a -3. Okay, so now let's actually practice doing our graphs for these. So for number 4, I said graph the function, make sure you include your asymptote, and state the domain and range. So if we have the graph f of x equals -4 log base 1/2 of x, remember what Mr. Baker was working on in the last section was you starting off with the exponential form instead. So if x is really x and our f of x was 1/2 to the x power, if we switched it to an exponential function and we used our x's of -2, -1, 0, 1, 2, then 1/2 to the -2nd power would make what? The negative makes a reciprocal, so the reciprocal of 1/2 would be 2, and then 2 squared would make 4. 1/2 to the -1st power would make the reciprocal 2. Anything to the 0 power is 1. 1/2 to the 1st power is a half, and 1/2 squared is 1/4. Okay, but that is not what we're going to graph. Then what Mr. Baker did was take that and switch it back to its logarithmic form. So if we say now that f of x is log base 1/2 of x, remember then you can just switch your x's and y's, right? So from my exponential graph, the x's were -2, -1, 0, 1, and 2. Those are going to become my y's now. And my f of x values are going to become my new x values. So log base 1/2 of 4 is -2. Log base 1/2 of 2 is -1, and so on. Okay? But I'm not going to graph that one either. What I want to graph is this function that they gave me. So now, if we're going to do the real function, f of x equals -4 times log base 1/2 of x, then I need to think what transformations are happening here. That negative sign out in front is going to be a vertical reflection. And the 4 is going to be a vertical stretch by a factor of 4. So we can deal with both of those at the same time if we take our y values and do what it says it's going to do. Because it's outside, it really does multiply by -4. So I'm going to take those y values and I am going to multiply them by -4. I'm going to keep my x values just as they were, 4, 2, 1, 1/2, 1/4, but I am going to take these y values and multiply each by a -5. So -2 times a -5 would be a +10. -1 times -5 would be a +5. 0 times -5 is still 0. 1 times -5 is -5. And 2 times -5 is -10. And then I can graph these points. So 4, 10 would be, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A little bit off my graph there, but that's okay. And then I am at 1, 2, 5. 1, 2, 3, 4, 5. And then I am at 1, 0. That's that basic point that all logarithmic graphs usually go through. And then I am at, oops, I totally graphed that point wrong, though. I was not paying attention. I was thinking exponential is at 0, 1. This should be at 1, 0 right there. Sorry, I totally goofed on that. That should be the point that all basic logarithmic graphs go through. And then 1/2 -5. 1, 2, 3, 4. -5. And then 1/4 -10 would be, again, a little off my graph there, about right here. So my logarithmic graph is upside down, and it's stretched vertically by a factor of 4. That's why it's so tall here. So remember, you always want this curving up slowly as it's going to the right, and then it's going down like this. I want to include arrows on both ends. And then I also need to put in my asymptote, because this graph did not move left or right any. There was no horizontal translation. Then my asymptote is going to be right here on the y-axis, which is the equation x equals 0. X equals 0 is the equation of the y-axis, and that's where our asymptote is. Our domain then, just like Mr. Baker talked about, is we want to look to the left. Where does the graph start? Well, it starts just after 0, and it goes off to the right forever. So our domain is going to be x is greater than 0. It doesn't actually hit 0 because there's an asymptote there, but it's everything to the right. It's everything greater than 0. And our range is all real numbers. That's going to be true of all of our logarithmic graphs for our range. Okay, so let's look at number 5. For number 5, I said we've got 1/2 log base 4 of x. So again, if I start off with my f of x is equal to, and I turn this into its exponential form, 4 to the x power, and I'm ignoring the 1/2 for just a minute. Then if I use -2, -1, 0, 1, 2, 4 to the -2nd power, the reciprocal would be 1/4, squared would be 1/16. 4 to the -1st would be 1/4. Anything to the 0 power is 1. 4 to the 1st is 4. 4 squared is 16. Then if we switch it back to its logarithmic equation, f of x equals log base 4 of x without that 1/2 yet, Then remember, I can just switch my x's and y's, so my new x's are going to be my former f of x's, so 1/16, 1/4, 1, 4, 16, and my new f of x's are going to be my previous x values, -2, -1, 0, 1, 2. But then I need to deal with that 1/2. So now if my f of x equation is really 1/2 log base 4 of x, then my x's are going to stay as they were in purple, 1/16, 1/4, 1, 4, 16. But now my y values are all going to multiply by half. This is a vertical shrink by a factor of 1/2. So my y values are going to become half as tall. And so my new y values would be -1, -1/2, 0, 1/2, and 1. So let's see what our graph looks like. Because again, this thing did not move left or right at all. I know already my asymptote is going to be in the same spot on that y-axis, which has equation x equals 0. And I'm going to try to graph these points as best I can. 1/16, -1 is about right there. We've got 1/4, -1/2 is about right there. Then we've got our 1, 0, which I'm going to graph in the right spot this time, and 4, 1/2. And then if we went way out to 16, I can't even get to that on my graph here, but about right there, 16, 1, then we would see that this is curving like this. It's getting really, really, really close to that asymptote, but not crossing it. And I want this to keep continuing forever to the right. And as it goes to the right, it's slowly going up as well. And so our domain would be just as it was before. X has to be everything greater than 0. And our range, remember, is all real numbers, always for these. They're going to go up and down forever. But the domain is going to change, I think, on the next one. So let's look at this last one, number 6. For number 6, I just did a couple translations. I moved it 1, and I also moved it 2, and so let's see if we can figure out what these are. That -1 is on the inside, so it does the opposite of what we think. It's actually going to move right 1. Which is going to move my asymptote right 1 also. So I'm going to go ahead and draw in my asymptote right now before I forget. And so my asymptote now has equation x equals 1. It moved to the right 1. And that +2 on the outside moves my graph up 2, but that asymptote goes on and on forever. So if I move it up 2, I can't really tell. It still has equation x equals 1. So again, let me start off with my f of x equals, and start with the basic without the translations. 3 to the x power would be that basic parent exponential function. And again, if we do -2, -1, 0, 1, 2 for our x's, plug those in. 3 to the -2nd power is 1/9. 3 to the -1st is 1/3. 3 to the 0 is 1. 3 to the 1st is 3. 3 squared is 9. And then I can switch it back to its logarithmic equation. The inverse of that exponential would be log base 3 of x. But I'm still not going to include the translations yet. So now I just switch my x's and y's. My x's are going to be 1/9, 1/3, 1, 3, 9, and my new f of x's, my y's, are going to be my old x's, -2, -1, 0, 1, 2. And now let's put those translations in. So let's think about this for a sec. If we are taking our x values and we are moving them right 1, then that's going to add 1 to each of these values, moving it to the right 1. So I would be at 1 1/9. I will be at 1 1/3. I will be at 2. I'll be at 4, and I'll be at 10. And then for my y values, we are really adding 2 because this is moving up 2. And so I can just add 2 to all of those values, and I end up at 0 and at 1, 2, 3, and 4. Okay, so if I start with that point that is at 1 1/9, 0, I would be about right there. 1 1/3, 1 would be maybe about right here. 2, 2, oh, that's a nice easy point to plot. 4, 3, 1, 2, 3, 4, 1, 2, 3. And then out at 10, 4. And you can see how this graph, as it's going to the right, is going up slowly. And as it's going to the left, it is getting closer and closer and closer to that asymptote, but it's not quite crossing it. Even if mine looks like it crossed it a little bit, just because it's hard to draw on the iPad. Okay, so our domain is going to be different this time, right? Because our graph doesn't start until just a little bit after 1. So our domain is going to be x is greater than 1. But our range is still going to be all real numbers because this goes up and down forever. All right, guys. So I again am giving you a worksheet for your last assignment. This has got to be turned in by Thursday. I think we have to have all of our grades inputted on Friday. So I hope you guys have a wonderful, wonderful summer. I will still have the same email address next year while I'm at Southwest, so email me if you need anything. My kiddos that had me this year, let me know if you need letters of rec or anything, okay? I hope you guys all have a wonderful summer. Take care, stay safe, stay healthy.